Now let's discuss the third type of partial fraction resolution. Well, the first type that we discussed, it had denominators with linear terms, like this term here. All of the terms in the denominator were like this, single linear terms. Now, in the second one, so let's just, for example, let's just write that down over here. So the first type, there was an expression, and basically we're concerned with the denominator. The denominator had basically x plus 2 and like x plus 3 and something like this. So in the second type, the denominator had basically something like this, x plus 2 to the power 3. And so this is the third type. In the third type, the variable has the power. As you can see, there is no variable over here that has a power in it. So this over here, we have a variable with a power. So how do we deal with this? Well, when you resolve it into its partial fractions in the initial step, you have basically this, you get this. Well, you have ax plus b over this entire expression that has the variable with the power. And then obviously you have this linear factor as well, the linear expression, and so you'll have to add that into the other partial fraction. Now, obviously, as with every other type of partial fraction resolution we've done, we'll take the LCM. So basically you need to get this denominator on the right hand side as well. So the ax plus b expression will be multiplied with x plus 3, and so will its denominator. So ax plus b will be multiplied with x plus 3, and c will be multiplied with x squared plus 1, and so will its denominator. And so the denominators are now equal to each other. They will be cancelled out, and so the numerators are now equated to each other. So you have this. Now, obviously, when you multiply these two expressions, this is what you'll get. And c will be multiplied with x squared plus 1, so you'll get cx squared plus c. Now, what will you do? Well, you have to, when you put in x is equal to 3 into equation 2, look at this. What was equation 2 actually? It was ax plus b into x plus 3. So ax plus b into x plus 3, and we'll basically add c into x squared plus 1. If I am not mistaken, let's just see. Yep, that's exactly what it is. So this is equation 2. When you plug in x minus 3 into this equation, this part becomes 0. And since this becomes 0, this also becomes 0 since it is being multiplied with it. So the left hand side, when you plug in x minus 3 on the left hand side, you'll get, whoops, let's just see what the left hand side is, 9x minus 7. So 9x minus 7 becomes 9 into minus 3 minus 7. And since this part becomes 0, it is now written down as 0. And c will be multiplied with x squared minus 1. So c will be multiplied with minus 3 whole square plus 1. And so after doing the calculations, the value of c you get is minus 17 over 5. Now, we have to equate coefficients on the left hand side and the right hand side. So equating coefficients of x squared and x in equation 3. Let's see what equation 3 is. Look at this. The coefficients of x squared are a and plus c. So a plus c are the coefficients of x squared. Basically, when you write down this whole expression, you get a plus c into x squared, and what is this? Yes, plus 3a plus b into x plus 3b plus c. So the coefficient of x squared is a plus c. So a plus c is equal to 0. Why is it equal to 0? Because as you can see, the left hand side which is basically 9x minus 7. It has no x square term in it. So the x square term is equal to 0. So a plus c is equal to 0. We found the value of c before. When you plug that in, you get the value of a as 17 over 5. Now we have the values of c and we have the values of a. Now let's equate the left hand side, the coefficients of x on the left hand side to the coefficient of x on the right hand side. So as you remember, let's see equation 3. In equation 3 you found this. This is the coefficient of x on the right hand side, and the coefficient of x on the left hand side is equal to 9. So basically 3a plus b is equal to 9. Now you do that, 3a plus b is equal to 9. As you know, we have already found the value of a, 17 over 5. So after doing the calculations, you find out that the value of b is equal to minus 6 over 5. And so you found a, b, and c. When you plug that into the original partial fraction equation that we made, you get this. And obviously, after putting down the 5 in the denominator and this 5 in the denominator as well, you get this. And these are the required partial fractions.